Hello students, this is a Maths Worksheet 56, chapter number 13, Symmetry. Now students, here we will discuss about symmetry of some figures. Let us now discuss symmetry of some standard geometrical figures. Symmetry of a line. A line has infinite length and hence it can be considered that each line perpendicular to the given line divide the line into two equal halves, mean parts. So a line has infinite number of symmetrical lines which are perpendicular to it. Also a line is symmetrical to itself. Mean this is a line, and if we draw a line on a perpendicular on it, so each line shows symmetrical part of line because line has infinite length. Now next, symmetry of a line segment. A line segment has two lines of symmetry, namely the line segment itself and the perpendicular bisector of the line segment or segment. If A and B is the line segment and we draw a bisector on it, so these are shows the symmetrical part of line segment, and this bisector divides, or this perpendicular bisector divides this line segment into two equal parts. Now symmetry of an angle. An angle with equal arms has one line of symmetry which is along the internal bisector of the angle. Like this figure. This figure shows symmetry of an angle. If this is an angle and here we draw a bisector on it, so this line divide this angle into two equal parts. So here this line is line of symmetry. Now symmetry of an isosceles triangle. An isosceles triangle has one line of symmetry which is along the median through the vertex. Median AD is a line of symmetry of isosceles triangle ABC, as the AB equal to AC. Here this is an isosceles triangle where two sides of triangle are equal. Here AB and AC are equal and BC with different length. So here we draw a perpendicular line on BC from A to D point. So here this line divide this triangle into two equal parts. So here this line is the line of symmetry. Now symmetry of an equilateral triangle. An equilateral triangle has three lines of symmetry along the three medians. Medians AD, BE and CF are the lines of symmetry of equilateral triangle ABC, shown in this figure. Here triangle ABC. So here medians are AD, first median, BE, second median, and CF, third median. So here these are three medians on triangle ABC. So here we say that there are three lines of symmetry on triangle or equilateral triangle ABC. Now symmetry of a parallelogram. A parallelogram has no line of symmetry, like ABCD parallelogram Now, symmetry of a rhombus. A rhombus has two lines of symmetry along the diagonals of the rhombus. In rhombus, ABCD diagonals AC and BD are two lines of symmetry. Like here, there is rhombus ABCD, and here two lines of symmetry DB and CA. So here we say that rhombus having two lines of symmetry. Now symmetry of a rectangle. A rectangle has two lines of symmetry along the line segments joining the midpoints of the opposite sides. In the adjacent figure, PQ and RS are two lines of symmetry of rectangle ABCD. Here we have rectangle ABCD. So here the rectangle having two lines of symmetry, QP or PQ or RS. So we say that rectangle having two lines of symmetry. Now symmetry of a square. A square has four lines of symmetry. Square has four lines of symmetry, two along the line segments joining the midpoints of opposite sides and two along the diagonals. So here we have square ABCD and square having PQ, RS, AC and BD as the line of symmetry. So here we draw line segment PQ along with midpoint, and RS and AC and BD. So there are four lines of symmetry. So we say that square having four lines of symmetry. Now symmetry of an isosceles trapezium. An isosceles trapezium has two parallel sides and two non-parallel sides of the equal length. In this figure, here the trapezium ABCD is an isosceles trapezium where two sides are equal, such that BC equal to AD, BC equal to AD, and AB is parallel to CD and AB is parallel to CD. It has only one line of symmetry along the line segment joining the midpoints of two parallel sides AB and CD. So here only PQ is the line of symmetry in this trapezium. Now symmetry of a kite. A kite has one line of symmetry along the diagonal BD. So here this figure kite has only one line of symmetry and the name of this line is BD. Now symmetry of an arrowhead. An arrowhead has the diagonal BD as the only line of symmetry. So here this is the arrowhead and the name of this arrowhead is ABCD. So here we say that BD is the diagonal and line of symmetry of this figure. Now symmetry of a semicircle. A semicircle has only one line of symmetry, which is perpendicular to the perpendicular bisector of the diameter AB. So here we have semicircle and the name of the diameter AB, and here we draw bisector on AB, O, and give name here P. So here we say that OP is the line of symmetry of this figure and on semicircle. Now, symmetry of a circle. A circle has an infinite number of lines of symmetry along the diameters. So here, this is the diameter of circle AB, and here we draw a line or symmetrical line on it along the midpoint. So here the first line, second line, third line, and fourth line. So here we say that there are many line of symmetry on circle. Now, symmetry of a regular pentagon. A regular pentagon has 5 lines of symmetry as shown in this figure. So here pentagon having 5 sides. Here we draw perpendicular on line segment or side DE. S to B same as E to Q, A to R, P to D, and Q to E. So here pentagon having total 5 line of symmetry. Now, symmetry of a regular hexagon. A regular hexagon has 6 lines of symmetry. 3 along the line joining the midpoints of opposite sides and 3 along the diagonals. So here there is a hexagon and the name of this hexagon A, B, C, D, E, F. And here we join one side to the other side of the hexagon like P, N, F, C, Q, R, and also join vertices A, D, L, M, B, E. So there are total 6 lines of symmetry. Now very important point, a regular polygon of n sides has n lines of symmetry. Now here we solve some examples related to above discussion. Now here scalene triangle. So here we have a name of shape and rough figure and number of lines of symmetry. So scalene triangle having 0 line of symmetry, isosceles triangle having 1 line of symmetry, and equilateral triangle having 3 lines of symmetry. Rectangle having 2 lines of symmetry. Square having 4 line of symmetry. Parallelogram having 0 line of symmetry. Rhombus having 2 line of symmetry. Line having infinite, this is a symbol of infinite, or we say that infinite number of lines of symmetry. Line segment having 2 lines of symmetry. Angle having 1 line of symmetry. Dear students, in this exercise I give some questions related to above discussion. So you will do all these questions in your homework. Thank you, students.